Very good stuff. Let's
Can
go.
you see my video? Yep.
Yes.
Hi everyone, I'm Paul Bond. I'm a postdoc at the University of York working for Kevin Cowtan, and I'm going to give a presentation on ModelCraft, which is our new automated model building pipeline that uses Buccaneer and lots of other programs. There's a website you can go to here. It's got more information on how you can install and use ModelCraft, but I'm just going to give a bit of an introduction. So this is a kind of general case of model building. At this stage in the structure solution process, you've got some initial phases, either through experimental phasing or from molecular placement. If you've come from experimental phasing, then you'll have done some density modification to get a map this good that you can build a protein into. If you've come from molecular placement, if you've got a very good molecular placement model, you might be able to skip automated model building and go straight to interactive building and validation, refinement. But if you're starting from scratch, or if you want to improve your model, it's always good to try automated model building to see if it can save you some time. So Buccaneer is a program for doing this, and Buccaneer internally has these 10 steps that I've listed some of here. So it first finds oriented residue positions. It then grows each one of those positions into a chain fragment, so you end up with multiple overlapping chain fragments. And then it needs to join and overlap, join the chain fragments that overlap with each other and resolve branches to try and produce single chains. It needs to sequence those chains, and then it needs to build side chains. So what Buccaneer doesn't do is Buccaneer doesn't refine coordinates and b-factors, so it doesn't perform global refinement. So when you use Buccaneer through an interface, either C64I or I2 or Cloud, what it's actually running is a Buccaneer pipeline that includes both Buccaneer and refmac. So refmac refines the coordinates and b-factors, produces an updated map and model, and passes those both back to Buccaneer for further building. The original pipeline that's in C64I or in C64 Cloud uses 2 or 3 cycles of Buccaneer followed by 10 cycles of refmac and repeats that 5 times. There've been a few more developments in C64I2 since then, where C64I2, instead of running only for 5 cycles, it now runs for up to 25 cycles by default, and instead of outputting the model from the final cycle, it outputs the model from the cycle with the lowest free R. But we kind of wanted to improve the Buccaneer pipeline, and this is kind of our motivation for wanting to do that. So initially, Buccaneer was tested on a set of experimental phasing structures, and it did very well. But more recently, we've tested Buccaneer on a large set of molecular placement structures, and some of these were quite poor. So there was some very poor models. There was some incomplete or partially wrong molecular placement solutions, and we ran the Buccaneer pipeline on those and found quite a lot where Buccaneer couldn't produce a very complete model, and somewhere we thought it should be able to. So we want to improve Buccaneer pipeline for those. Also, we don't want to just build a protein, we also want to build RNA and DNA in the same pipeline, and that's in ModelCraft at the moment. We also would like to build other components in the future, so sugars, ligands, modifications as well. It would be nice if the pipeline just did everything it could. And finally, we want those developments to be shared between all the different interfaces, so it doesn't matter whether you're running it on the command line, you're running it in I2, or you're running it in Cloud. You end up running the same pipeline with all the newest developments, and it's essentially the graphical interfaces would just call the command line, and then we only would need to make development in one place. So those were our motivations for making ModelCraft, which we did. And this is how the pipeline looks at the moment. So I'm just going to go through this briefly, and then I'll show a bit more of a visual example. If you provide a model, an input model to ModelCraft, it refines that with sheetbend and then refmac, and then a single cycle of ModelCraft has these 7 steps. Firstly, it prunes residues using Coot. That is only done if the resolution is better than 2.3 angstroms. Then it uses Parrot for density modification to try and improve the map. It adds dummy atoms into the map using Coot and refines those. Now these dummy atoms aren't interpreted, the dummy atoms are just used to try and improve the phases. the phases from the dummy atoms are only accepted if adding them leads to a lower free R factor. If not, then the map from Parrot's used instead. The fourth step is to build protein using Buccaneer, and then there's another pruning step, but just to prune whole chains. So sometimes Buccaneer might output lots of small chain fragments, and in that case what you sometimes want to do, it depends on the chain fragment. If it's built in a place where it shouldn't be, which sometimes happens, then you want to remove those from the model, and this step helps to do with that. So for instance, if you've built some protein through a ligand or through one of the RNA or DNA chains, hopefully it doesn't fit well, and this step can hopefully recognise that and remove them from the model. Then there is a step to build RNA and DNA using Nautilus, and finally a step to add waters using Coot. Most of these steps are followed by RefMag. The adding water step at the end, again, is only accepted if the free R factor improves, like when the dummy atoms are added. These 7 steps make up a single cycle of ModelCraft, and that runs for up to 25 cycles. It stops if R3 stops improving for a set number of cycles. And then if your resolution is better than 2.5 and your R work is better than 30%, there's a step to try and rebuild sidechains in Coot. So I'll take you through an example of this where it was a difficult molecular replacement problem. It was a poor starting model where ModelCraft managed to improve it quite a lot. So the target data is 2.25 angstrom resolution, and it's aiming for a protein with 4 copies of a 435 residue protein. Now, I took a model from AlphaFold, got rid of residues with sort of high uncertainty, and then used that as a model in ModelRep. Now, ModelRep managed to place 3 copies correctly, but one of the copies was placed incorrectly, and what we're looking at here is a view of the incorrectly placed copies. So the density for this isn't very good, and the R3 for this overall model is 54%. And it's stuck at that. So it was 54% after ModelRep, and after refining with Sheepbend and RefMag, it's still 54%. Hasn't managed to improve the model very much. After we've done 3 cycles of ModelCraft, the picture looks quite different. So this is the same view, but it's not very recognisable. So this is the starting model, and this is after 3 cycles of ModelCraft. And what you can see is that ModelCraft's removed a lot of the protein in this region, and Buccaneer's built a few small fragments. And the free R factor has dropped to 50%, which is better, but still not great. And it's in cycle 4 that things start to improve more. So the first step is to prune residues. So we can see in the top left, there's been some residues pruned, and the density for those residues has disappeared when we've deleted them and refined again, which suggests to us that this density is maybe only here just due to noise and model bias. And really it probably should be building out in this direction. The next step is density modification using Parrot, and in this case Parrot's done a very good job. This map looks a lot more like a protein region should look compared to the previous one, which is very noisy. And you can kind of see a helix at the top. The next step is to add dummy atoms into the map from Parrot and refine those. So this is hopefully to try and improve the map even further. The free R factor has dropped to 32% compared to the previous 50% when this model was refined. So this map is then accepted as the map that Buccaneer is going to build protein into. Buccaneer then builds a protein model, and in this case it's done very well. It's built this helix at the top, and it's built most of this correctly. There's a few things wrong. So there's tryptophan residue at the bottom, needs to be moved. And in the bottom right, there's quite a lot that needs to be fixed. And the free R factor is at 33% without any dummy atoms, so it's 32 with the dummy atoms. Buccaneer has built protein, it's 33 without any dummy atoms. And then if we run another cycle of ModelCraft, that fixes a lot of these issues and gets the free R factor down to 26%, which is the model that's output from this. And there's still things that you'd need to do to tidy up this model in Coot afterwards. For instance, in the bottom right you can see a twisted peptide indicated by this yellow flag. So there's things you need to fix, but ModelCraft's done a good job at fixing this incorrectly placed chain from molecular placement. So that was kind of one example. This shows a mass comparison of the old pipeline from CSP4I and the ModelCraft pipeline. So this shows the completeness of the protein model for 3,000 molecular placement structures and 1,200 experimental phasing cases-ish. The molecular placement structures are all alpha models that I've picked a single PDB target entry for, and the experimental phasing structures are all JCSG entries where the experimental phases have been deposited. Now, there are a lot of cases in both of these test sets. In the top right, where it didn't really matter which pipeline you used, both pipelines produce very complete models. And there's also a lot of cases in the bottom left where neither pipeline, or there's a few cases anyway, where neither pipeline managed to build a very complete model. But there's also quite a lot where CSP4I didn't produce a very complete model, but ModelCraft did do a lot better, sort of in the top left, which is good. Unfortunately, at the moment, you can only run ModelCraft through the command line. So you can install it using pip for Python 3.7 or newer. And this is a bit of an example of how you would run ModelCraft. So you need to give it a description of the asymmetric unit contents. You need to give it your data in MTZ format. And if you're starting from a model, you need to give it a model. There's more help on how you use that if you use the help option. And if you go to the website, there should be a bit more help as well. Graphical interfaces are coming soon, hopefully, so there should be interfaces in both i2 and Cloud soon after CSP4.8's been released. So here's just some tips on running ModelCraft, what you might want to do to try and get the best and make it work for you. So I said you need to give it a description of the asymmetric unit contents, and there was a JSON file. You can give it a sequence file, for instance a FASTA file, and that'll work fine a lot of the time, but if you've gotten an uncommon solvent contents, then it's best if the program doesn't have to guess the number of copies, and then I would recommend using this newer JSON format, which you can find more information on the website about. It lets you specify the number of copies so that you can give Parrot a more accurate sequence, solvent content, and give Parrot a lot more chance of doing a good job. Also, kind of unlike my example, if you knew that part of your model was wrong, if you knew that you'd placed 3 chains correctly and 1 incorrectly, it's probably best to just delete the incorrect parts of your model and prune those away before you start ModelCraft and give it a better input model. It's also worth including non-incorporated heavy atoms in the input model, so don't pass it selenium from selenium-methionine proteins, because it'll want to build the model through those. But if you know the location of other heavy atoms that aren't incorporated in your protein and RNA models, then it's worth including those, because it'll stop the program building into those, and it'll help improve your phases as well. If you've tried ModelCraft and it didn't produce a very good model, there's a few things you can do. I would try improving your initial model before you submit it, try improving your phases through some other density modification programs, or you can take the model that ModelCraft's built, so maybe it's built a partial structure for you, and then you can try and improve that and resubmit it to ModelCraft and see if it improves it. And you can also just try other model building programs. I'd recommend just trying as many as possible. You can try other programs either with the same input that you gave ModelCraft, or you can try them with a partially built model from ModelCraft, and just try as many things as possible. And once one of them works, you can run them in the background, so I would just try those. So here's just some other pipelines that you might have to try for model building. There's Crank2, which is used for experimental phasing. There is CSP4 build in Cloud. There is CAB in the SIR suite, and those 3 pipelines all use Buccaneer as well. There is ARPWARP and ShellXE available through the CSP4 suite. ShellXC has just been updated so that it has an option to also build side chains. And finally, Phoenix Auto Build is a very good model building pipeline in the Phoenix suite. So I'd like to give special thanks to Kevin, Keith, Eleanor and Martin, and thank you for listening. Hi, sorry to everyone who had problems with that video. It will be posted online afterwards, so people can watch it with video as well as sound.
Thank you, Paul. I think quite a few people were able to watch the video as well as hear the sound, and we've got time for maybe 2 questions. I'll pick some from the Slack. One of the questions is probably the most obvious one. Is there a resolution limit for the use of ModelCraft? And if so, what is it?
Not so much as a limit. You could try it with any resolution data. As you get to low resolution data, the chances of it working get less. And there's a couple of things there. So one is your resolution, and one is the quality of the phases that you're starting ModelCraft with. So if you're starting from experimental phasing, you've got really good phases, or if you've got a really good molecular replacement model, then there's more chance that it's going to work at low resolution. It starts to drop off past, say, 3 angstroms towards 4 angstroms. I think you would really struggle as you get close to 4 angstroms. Around 3, with good phases, it can quite often work.
That is very encouraging, thank you. Perhaps 2 more. If we have a case with 4 copies in the asymmetric unit, was Parrot able to apply at least some NCS in density modification?
So yeah, I checked this specific example that I showed where there were 3 copies that were correct and 1 that was incorrectly placed. So that specific Parrot step that I showed couldn't pick up any NCS to the copy that was misplaced, but there was NCS found between the other 3 copies used in Parrot. So it had pairwise operators between all those 3, but it was still enough to improve it in the other copy.
That's brilliant. There was another question about NCS, so probably this answer covers that. And here's a question from Paul Emsley. How about a Coot interface? Then you can see dynamic model updates as the pipeline progresses. I like the idea. What do you think?
Yeah, sounds like a good idea. I guess you would just need to output lots of intermediate models and keep showing them in Coot as they update. Yeah, sounds good.
That sounds a very interesting idea indeed. So on that note, shall we thank Paul Bond and move on to the next talk? Our final speaker in this session is Tristan Kroll, who did his PhD, which I believe in biomaterials research in Australia, but who is a structural biologist right now in Randy Reed's group in Cambridge, UK, working on Isolde. Isolde is a new way to fit molecules into maps using molecular dynamics, but Tristan does it in an interactive fashion. Lately, Tristan has been experimenting with high quality model prediction by AlphaFold in Isolde. So let's hear Tristan talk about these new exciting developments in Isolde. Over to Tristan. We can't hear you, Tristan. We still can't hear you. No, still no good. So while Tristan sorts out his audio, maybe we can take another question to Paul Bond. Is there an advantage in using the output MTZ file from Phaser with file calculated and form in ModelCraft?
Probably not, I would say. If you've just used Phaser for molecular replacements, I would give ModelCraft the placed molecular replacement model. One of the first 2 steps of ModelCraft are to try and refine that using sheetbend and refmac, which is kind of similar to if you're using Phaser through the I2 GUI, for instance. And then ModelCraft will start from that. If you've got some other better refinement, then you would just give it your starting model. But I would just give it the model if you're starting from molecular replacement.
Great. And there was a comment, not really a question, at least it didn't have a question mark in it. It says, Buccaneer always places the wrong orientation of tryptophans for me. Can you comment on that?
Yeah, it's something we've looked at. Part of the problem here is tryptophan rotamers. I think by default in the Richardson rotamer library there are something like 7 tryptophan rotamers, but really there is a bit more flexibility there. So quite often a problem is you'll get it reversed in density.
No, apparently not.
What? Sorry, what was that?
Oh, I was just going to wholeheartedly agree with you. It's my experience that the case is that there is not enough variation in the tryptophan rotamers, and what we need to do is create a couple of chi variants of chi1 and chi2 either side of each of the whatever it is 6 or 7 rotamers. I think that will do the trick.
Yeah, I think so too.
Yeah.